Hi everyone, this is the project presentation by Aditya Katakam and Vishnuteja Muktineni about role of materials used in ocean sea expeditions. This project is done in the coursework of IT 283 Advanced Materials and Processes under the guidance of Dr. Arun N. Nambia. This is the outline for our project. In this outline, we discussed about introduction, problem description, research findings, offshore oil rigs and the types, drill bits in oil rigs, materials, manufacturing process and properties of drill bits, and the later stages will be discussed by my colleague groupmate Vishnuteja Muktini. In this outline, we also suggested about future directions and conclusions about what materials would be used to get the proper yield from ocean sea expedition. Introduction. In ocean sea expeditions, materials play a vital role because they are supposed to work in extreme working conditions. So, materials used in ocean sea expeditions should not get affected due to environmental impacts such as corrosion of parts, degradation of materials. There are many situations where real-time ocean and sea expedition works fail due to improper material selection process. And because of due to this improper material selections, many operators of oil rigs has faced huge economical crisis. So, special concern must be provided for the material selection process in ocean sea expedition work. Problem description. The materials used in ocean and sea expedition works are expected to work in water bodies throughout its lifetime. Therefore, the materials used to manufacture the tools and machineries of ocean sea expeditions must have unique properties such as low thermal expansion coefficient, high corrosion resistance, excellent toughness, high working hardness. Therefore, if the materials without the above stated properties will lead to failure. So, this trending problem in the ocean sea expeditions must be attained by using modern technological developments in material selection process. Research findings. Drilling rig is a machine capable of creating deep holes in the ground surface. There are two types of drilling rigs available. One is land-based drilling rig. These drilling rigs are which can be transported from one site location to another by means of trucks, tracks, etc. And the other one is marine-based drilling rig. In these marine-based drilling rigs, there are two types available. One is onshore oil rig and the other one is offshore oil rigs. In onshore oil rigs, these are settled on the surface of land, where natural oil deposits are available. The oil is extracted by using sucker rod pump mechanism, whereas in offshore oil rig, they are settled on the surface of ocean and sea floor. As our topic is related to materials used in ocean sea expeditions, so we are more focused about offshore oil rigs. Offshore oil rigs and their types. In these, we discussed about different types of offshore oil rigs available and the materials used for the manufacturing of oil rigs. The offshore oil rigs are the large structures which use machinery to drill wells into the ocean sea floor to extract fossil fuels from the ocean seabed. Offshore oil rigs and their types. There are different types of offshore oil rigs available. The first one is fixed platform. This platform is operated at the depth of 1500 feet. Materials such as steel bars and concrete is used to construct fixed platform offshore oil rigs. In this, the base of the offshore oil rig is fixed to the ground by using steel frames. It is so rigid that it will not get affected due to winds and tides. Next form of ocean floor oil rig is compliant towers. This oil rig is used when the ocean depth is 1500 to 3000 feet. This platform is similar to the construction of fixed platform but has more improved structural design with narrow frame construction. The next one is sea star platform. This operates at the ocean depth of 500 to 3500 feet. Structural design of this platform is different, having tension legs made out of steel ropes to support platform. In this, the grounding is made by using anchors. Floating production system. This operates at the depth of 1500 to 6000 feet. Ships are used to extract fuels to the shore by reducing the overall weight on the platform. Same materials are used for the construction of this oil rig. Offshore oil rig and the types continued. tension leg platforms. This operates at the depth of 1500 to 7000 feet. Long flexible tension ropes are used to attach the platform to the ocean floor. These ropes are made using duplex steel. This duplex steel has better corrosion resistance and crack resistance. The other offshore oil rig is subsea system. This operates at the range of 7000 feet. This system is completely set up on the ocean bed. This system can only extract the oil from the ocean bed, but it don't have the ability to drill the holes. These are programmed only to extract the fuel. Spur platforms has the highest operating range of 2000 to 10,000 feet. Large cylindrical structure is made to support the platform. In these, cables and chains are used for fastening purpose. From the sources we found out that Peridito is the largest oil rig in the world and it has constructed according to the spur platform structure. In this, all the platforms are rigid to hurricanes, ocean floor movements because of due to the improvements in materials used. Platform materials must have capability to withstand large weight and should resist to impacts of tides. Drill bits in oil rigs. There are three types of drill bits available. This figure shows about the three types of drill bits. The first one is roller cutter bits. The roller cutter bits is divided into two types. These can crush rocks very efficiently without any wear on the tool. One of the form of roller cutter bits is steel insert bits. These steel insert bits are soft and used for greater penetration. And the other one is carbide insert bits. It is used for odd surfaces, they have small protrusions on them. The other drill bit is long tooth millet bits. They are very efficient at drilling operation due to long teeth shape. They can work in chalk and cemented sands. Fixed cutter bits. They use polycrystalline diamond compact cutters to shear rock with a continuous scraping motion. These bits are about 1/8 inch thickness and about half to 1 inch diameter. In this, diamond is also used as a bit material along with thermal stable polycrystalline. We also discussed about materials, manufacturing process and properties of drill bits. Diamond. It is the hardest material known to man. In these, diamond grains are embedded into tungsten carbide blades. The diamond is used according to the industry specified grades. The diamond which used for drill bits is 10 times harder than the steel, 10 times more resistor than the tungsten carbide, 20 times more strengther than the granite. To explain about the manufacturing process of diamond, raw materials like graphite and cobalt are stacked in small cans and pressed to 2000 million psi strength, followed by heating to 2732 degrees Fahrenheit for 5 minutes. This process of heating creates small crystals of synthetic diamonds that bond together to become polycrystalline diamond compact, which is also known as PDC compact structures. The property of synthetic diamonds is also discussed. The diamonds have high thermal conductivity which helps to flow the heat from the tool to the other parts of the tool, and the other property is low thermal expansion coefficient. Because of due to low thermal expansion coefficient, the tool will not get shape out and they stay in their proper form. The other form of property is low coefficient to friction. The diamond has good coefficient of friction, so the parts on the tool will not get worn out during the operation. We also discussed about manufacturing process and properties of tungsten carbide. Tungsten carbide is the hardest material close to diamond. It's a kind of steel comprised of tungsten carbide and cobalt. In this, the cobalt is used as a binder and improves shock resistance. It has the tensile strength of 100,000 to 500,000 psi and Brinell hardness of 2570. In tungsten carbide, tools are stronger and has longer life when compared to other hardened steels. We also discussed about manufacturing process of tungsten carbide. This material generally starts as powder. A small amount of wax is then added to the mix of powder. The wax holds the material together so that they can be molded. The mix is then placed in a dewaxing furnace for overnight. When removed from the furnace, it appears like chalk in a solid form. As a result, the output material obtained has high strength, toughness, and high hardness. We also discussed about the properties of tungsten carbide. The properties are high compressive strength. Because of due to high compressive strength, the tools will not get breaked out in the operation. The tungsten carbide has higher melting point which helps to operate the tool at very high temperatures so that the tool will not get deformed due to temperature impacts. And the other form of property is high modulus of elasticity.
Hi everyone, my name is Vishnu Teja. Here I am going to discuss about the cruise liners, submarines, and followed by future directions, and finally conclude with the conclusion. Cruise liners. Cruise ships are the passenger ships used in pleasure trips and vacations that are usually large and can accommodate thousands of people on board, which depend upon the size of the ship. Most of the ships have small rooms, so many may not consent to spend more time in there as the rooms are less expensive than others. The rooms which have extra space are more expensive and have more facilities in it. It is clear that on a voyage a ship needs many types of materials and different components. Moreover, the time of ship construction may need different types of metal alloys and different types of techniques in the construction. Types of cruise ships. Mainstream cruise ships. These type of ships are quite common as these are marketed to fulfill the need of majority of passengers with maximum resort features. Mega cruise ships. These ships can carry about 4,000 to 5,000 persons on board, and they are larger and sophisticated with maximum facilities. Ocean cruise liners. These are constructed in such a way that to withstand the ocean harsh conditions while on long voyages. They have high standards of construction. Luxury cruise liners. These ships are equipped with sophisticated and technological advanced systems and with high standards of luxury and features. Small cruise ships. These ships carry few hundreds of people on board by offering more intimate and relaxing experience in a short voyage. Adventure cruise ships. These are used in individual visit to remote places. These are equipped with advanced technology and survival service arrangements required for the voyage. Expedition cruise ships. These are ships that are used in expedition in search of research findings to a critical harsh conditions which are remote destination. These are also called icebreaker vessels. River cruise ships. These can't carry more than a few hundred of people. These are designed to navigate rivers and inland waterways. Materials used in construction of cruise ships. The materials used in construction of ships should have properties of toughness, ductility, malleability, and corrosion resistance, which are essential for the sea voyages. The important material of all is steel, which should be a heavy metal sheets and plates with good combination of different properties of alloys. As steel used in the construction undergo different thermal treatment which reduces the alloying materials and gives strength. Paint is one of the most essential work that is to be done after the construction of the ship. It consists of three components: pigment, a vehicle, and a solvent, depending upon the paint that is used. It helps steels from getting corroded from seawater and for a long time, and also helps in reducing friction from water while sailing. A ship is a large structure and cannot be painted frequently, so A spray system is used in order to paint the whole part in a multiple layers of painting. Manufacturing process of shipbuilding steel. The first step of the process is melting the raw materials, followed by forming process where steel is molded into desired shape, and then the heat treatment. It is done to improve the structural properties by heating and molding steel in furnace. Later coming with descaling, removing the cracks and prevent cracks, and then cutting steel ingots for commercial, and finally finishing process of the material. By this method, the corrosion resistance, high ductility, and better resistance to stress can be obtained. Welding process in shipbuilding. Welding is the most important process in shipbuilding, as each and every part is welded by using sealing materials to attach at high temperatures. There are different types of welding techniques which are used in different parts. Some of the techniques are gas metal arc welding, which uses compressed silicon with copper alloy as a sealing agent. Low carbon steel and aluminum welding is done by lap joint and laser technology. Submerged arc welding, followed by shield metal arc welding and gas tungsten welding. These type of weldings are used at different parts of the construction in order to join heavy sheets and small instruments to the ship's mainframe. Submarines. Submarines are used mostly by armed forces in defense fields. They are built to travel and to stay a long time underwater. It is made up of high resistance material in the construction of the body to withstand greater pressures and impacts when underwater. The outer surface of this submarine is known as hull. It have to withstand the greater depths of 1140 feet, so it is made up of high strength alloyed steels. Most of the submarines will have two different hulls in order to withstand any accidents. Most of the submarines will be running on fossil fuels, and the submarines which stay longer in their missions will use nuclear power, where uranium is used in the reactor to power up the engines. Types of submarines. Pleasure submarines. These are used for the pleasure purpose. They won't go to the deeper depths of the sea. They're just used for the admiration of marine life, and they are small and too expensive. Military submarines. These are used in naval wars and upholding the nuclear weapons. Most of the largest and expensive submarines are used in the military all over the world. Scientific submarines. There may be different sizes of scientific submarines. Among them, the submarines are mostly used for expeditions and research purposes. This helps in investigating of the bottom of the ocean leaks and can help bring back the biological samples. These submarines are made up of cellulosic foam, which is composite material have hollow microspheres implanted in large structures. These help in maintaining the pressure without getting crushed. Different types of materials used in submarines and their properties. Materials used in submarines should withstand greater pressures at different depths of the sea. The pressure force that acts on the sides are prevented by hulls. There are two hulls, namely inner and outer, which function separately, and the space between is filled with water or air. The outer hull is made up of mild steel and reinforced plastics, as this hull will not contain any pressure-sensitive materials except the anchor. Inner hull is soft it cannot withstand greater pressures, and this part and the crew members and all the equipments are placed in this hull. Properties of materials used in submarines. The materials used in the construction of submarine should have the following properties. The first thing is they have to withstand high amounts of underwater pressures when their submarine travels at a lower depth. The ability of metal that can be bent into one thick sheet to make it as a hull. The material should be lightweight, which helps in fast moving and effective when they're traveling underwater. They should be non-magnetic for stealth and avoiding have magnetic signature that can be tracked. Material behavior in cold free water depth in ocean. Materials used in ocean and sea expedition have low thermal expansion coefficient, which helps materials to restrict the changes in the metal due to the cold freeze water. Submarines are made using high-strength materials to resist from degradation of the materials due to exposure of chemical agents in the water. In some cases, robotic machines are used to resist the changes in the cold freeze water. At different places, we have difficult situations. At this time, we use the robotic machines and they have the capability to withstand all the changes in the climate. Future directions. The better improved techniques for underwater welding is adopted to decrease the oil spilling due to the leakage of the pipes carrying fossil fuels. Almost all the materials are replaced with alloying materials to give additional strength to frame holding the oil rigs. Followed by remotely operated vehicles like ROVs are used to reduce the human involvement to do underwater works. Autonomous underwater vehicles are used to repair works and the damaged structures. Conclusion. Improvements in materials will increase the efficiency of oil rigs and other materials used in construction of cruise ships and submarines and many other vessels. Materials used in oil rigs must be withstanding high temperature resistance properties, such as low thermal expansion coefficients. Strength tests must be made before using the material in the frame of oil rigs, such as universal testing machine is used to determine the material strengths. If the material having defects are used in the construct ocean and sea expedition missions, they will cause further losses to the operation. So a special concern must be made in order to overcome these problems while selecting the materials which have better properties. Thank you.